Good day, and welcome to CFE Media's Virtual Training Week. For this session on keys to reliability and security for industrial control systems networks, we'll be joined by Mark Imordino, Field Product Training Engineer with WAGO Corporation. I'm Kevin Parker, an editor with CFE Media. CFE Media has met the standards and requirements of the Registered Continuing Education Program. A certificate of completion will be available to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RESET. When considering best practices for industrial control networks, there are many features to explore, regardless of whether your primary concern is network structure, access, or security. It is not only industry standards that need to be explored, but also whether your plan is for a reliable, efficient, and secure system solution. In this session, we will look at some of the keys to achieving these goals for an industrial control network. You see before you the learning objectives for today's session. To get the most out of today's session, please bear in mind the following. Attendees are eligible for 1 PDH credit for this event airing on October 20th, 2021, and is categorized within the technical health and safety categories, including core technical category for RESET. We'd now like to share with you a brief video from our sponsor, WAGO Corporation.
Welcome to WAGO's North American headquarters located in Germantown, Wisconsin. As the innovators of cage clamp, WAGO has been the world leader for over half a century in the design and manufacture of termination systems incorporating spring pressure connection technology. We have been changing industry with our innovative products since our founding in 1951. Today, our company offers a full range of products including electrical interconnect such as rail mount and PCB terminal blocks, electronic interfaces like power supplies and signal conditioners, and automation products including I/O systems and touch panels to serve a multitude of industries including manufacturing, lighting, process, and more.
Welcome back. I'd now like to introduce today's presenter, Mark Imordino. Mark Imordino is the Field Product Training Engineer for WAGO Corporation. Mark conducts seminars and training courses, as well as presenting YouTube videos and e-learning modules covering a broad range of WAGO products and applications, with a focus on automation, programming, and system design. The training courses cover the implementation of WAGO hardware and the use of either the Codesys 2.3 or e-cockpit programming platforms. Mark has been in the automation industry for more than 23 years. Before working with WAGO Corporation, he worked for systems integrators designing control systems and machine safety systems for various factory automation applications. Mark, welcome to today's session, and please go ahead.
Thank you so much, Kevin. All right, guys. So today, our focus is going to be on industrial control system networks and focusing on the keys to reliability and security. When we connect to the outside world these days with a lot of these industrial control systems, of course, there are a lot of things that people are concerned about with these networks. And those two primary things are reliability and security for the network and their data, okay? So again, that's going to be the focus of this presentation, and then we'll just go into some of the topics and talk about what we're going to actually cover here. So the first thing we're going to cover briefly is just talking about that modern factory data flow, okay? How are we trying to get information from our plant floor to outside resources to cloud connectivity systems and what we're doing with that data? And, why is it so important? And of course, what do we need to do to protect that data? not just from a information standpoint, but from a security standpoint and making sure someone's not coming into our network. We'll take a minute to look at some network devices, just a brief discussion about the difference between an unmanaged and a managed switch. And then we'll look at some of the key points for the reliability and security that we mentioned before, which is network redundancy and the different aspects of that and different options, of course. Network security, the various things that we can do across the network to ensure our data is protected. Data transmission to ensure that certain things aren't done on our network to impede our data transmission. And then network performance as well, looking at things that we can do to keep people from maybe doing things like a broadcast storm or something like that on our network. And then finally, I just want to cover some best practices with regards to security, things that you should be considering, things that some people overlook, and kind of talk about the different layers of things we should be looking at, kind of outside the managed switches, but a little bit of talking about inside those and how they apply to the systems. So looking at a smart factory, there are several things that the two technology worlds that we live in, if you will, have to share this information. And it's that convergence of operational technology, which is our industrial control side, if you will, and our information technology, which is our IT. And so with these two worlds, we've been trying to bring them together, and we have brought them together for several years now. I can remember going back in the 90s when I first started doing this. It was this big thing about how do we get information from one platform to another so we could see this information, use the data that's out there regarding our productions, our, over-the-air updates for the system. How do we make things transparent as far as live metrics that enable fast decisions on our production, and how efficient is our system. Do some preventive maintenance and being able to look at predictive failures and being able to react to that before anything actually happens with the system and shuts it down, and with that real-time monitoring. Also, adaptive scheduling. How do we look at our systems and change how we do things, or maybe change our manufacturing schedules based on production runs? So, it's that convergence of these two worlds that makes things kind of complicated, because we're pushing this data, of course, out into the cloud. And there are various groups within organizations that want to see this information, but there's also various organizations, right? So different divisions of the company that want to see this information could be in different states. So we have this operational technology, as I mentioned, which is your engineers, your maintenance people, and that's typically your PLCs, SCADA systems, and then your IT people, which is your management, accounting, data coming out to the cloud, web services, and ERP systems. So when you talk about switches, there's basically two versions. There's an unmanaged switch, which is very simple. It's a plug and play device. There's nothing really to set up. You apply power to the device, you connect your network devices to it. No special installation or configuration required. It just basically, you plug it in, it auto negotiates between the Ethernet devices, and you're good to go. So there's not a whole lot to do, which is great, but it doesn't give us a whole lot of protection either, because it's just plug and play. So we're not establishing any security measures or protecting our network from anything malicious potentially. So although these are great and they can be used in combination with managed switches, by themselves are not enough to get that reliability and network security that we're looking for. So that's when we go, we move on to the next topic with regards to managed switches, okay? And what do they bring to the table that's different than an unmanaged, for example? First off, network traffic. So there's all kinds of things that we can do with regards to storm control, bandwidth control, link aggregation, and we're going to go into all these subjects a little bit deeper, but just giving you an overview of what the different things that we get from a managed switch. Another thing to consider, of course, is redundancy. There's several options on that. You can use ERPS, dual homing, express or jet ring options, dual ring, and so forth. Another thing is data transmission. So we have our VLANs that we can set up. Either these can be IP-based or MAC-based VLAN setups to, again, control our data transmission, who's getting what information. And then lastly, there's our security measures that are built into a lot of managed switches today, from authentication to firewall protection, port security, and even service controls. So what we're going to cover first is a little bit on the network redundancy side and what are our options. And there are a lot of them, and they have different benefits depending upon your network size, the number of devices and things of that nature, and what the devices itself support, okay, with regards to the various PLCs and other switches we may use in the system. So first one is jet ring. Basically, this is redundancy with a single open ring. You can see in the illustration here, we have this loop back on itself, if you will. And of course, in a standard Ethernet setting, we could not do that without some type of managed switch. The recovery time on this is right around or just under 300 milliseconds. It's very easy to set up and configure. This does operate off for both copper and fiber optic ports. The managed switches obviously have to support jet ring configuration, but the configuration is managed through there. Several devices out on the market offer like a web-based tool where you can go in and configure this device. It also does require that the field devices, PLCs, and things of that nature have an integrated switch and fast aging option with regards to the switch built into the device. Another option is express ring redundancy. The recovery time on this one is just under 20 milliseconds. Again, another one of those that's fairly easy to set up and configure. A lot of times what we're trying to do with the express ring is make these connections between our managed switches and then, set that communication up to, again, bring that uptime down to less than 20 milliseconds, or excuse me, downtime down to 20 milliseconds. So with these, typically, again, we're connecting these devices together with the managed switches in this express ring configuration. And again, it's real easy to set up. Each one of these would have its own web-based management tool, if you will. Just use a simple browser and you would go in and configure that device. And then we have some technologies where you can combine the features and benefits of each one of these. So for example, with a dual ring option here, you're combining a jet ring and an express ring together. You get that quick recovery time. So again, the whole point in redundancy, of course, is if there's any break anywhere in these lines, we can recover the network quickly through an alternate path, right? So when you look at a recovery time of less than 20 milliseconds, that's really good for systems across the board, Ethernet-based systems, so that we don't have a large downtime or a loss of communications. It comes right back pretty quickly. And with these, again, you have to have that where it's built-in options for supporting both of these in order to, incorporate the dual ring functionality. Again, fast aging is required, things of that nature. But again, this is handled within the managed switch as far as setting up the jet ring and then the dual ring connection with the express ring as well. And then another option, popular option is ERPS, or Ethernet Ring Protection Switching. It's standardized, it's open technology. Just about every device out there is going to support some form of this, or a lot of devices, I should say. The response time as far as an alternate path is less than 50 milliseconds. You can have up to 6 nested rings per switch. And then of course, what we're trying to eliminate is that single point of failure. So any one break in a connection here doesn't cause a failure across the entire network. So again, with these, you can set up your major ring, your sub rings, you're connecting your PLCs, you're configuring this through the other managed switches and the ports where they connect together. And of course, with the HMIs and the screen interfaces as well. The next topic I want to cover is network security. Okay, and there's a lot of aspects to this, so we're just going to jump up to like the 40,000 foot view. But One of the key things, of course, is some type of authentication. So you want to make sure you have some type of authenticator or authentication service. So you have these Radius servers, where what this allows us to do is have the secure authentication and authorization with a server that pairs up these devices, if you will, where you have this authentication information from a subscriber, or supplicant with the authentication server, okay? And the switch here is acting as the authentication between the supplicant and the authentication server, verifying that this device should be allowed to communicate on our network. Okay? And there's a little more detail on this in a minute. So here you go. To give you some more details, this is, again, based on the IEEE standard 802.1x. Again, we would have a Radius server built into our network, and then we would set up these devices, like I said, the managed switch as your authenticator and your PLC, HMI, whatever, as a supplicant. So the supplicant is just basically a client that runs on the endpoint and submits credentials for authentication. The authenticator takes this information, says, okay, this device is, I'm going to take this data and transmit that to the server, the authentication server, and the authentication server just validates, hey, this device has the appropriate credentials and is allowed to be on our network and transmit data, okay? So why does, this type of security matter? And there's several layers to this. Again, we'll look at some of these, but, these are some of the attacks that can occur and why we have to have, like I mentioned, the previous authentication system in place. So there are several of these. First of all, of course, is the MAC address flooding attacks or denial of service. Basically, what you have is this CAM table, or content addressable memory table, that's created within the switches themselves. It stores information about the devices connected to the network and everything, regarding parameters if you have a VLAN setup or something. And then, of course, these tables, these CAM tables within these switches have a fixed size. And what can happen is they can flood the network with requests. And once it's flooded and you have so much information in the CAM table, then it can't update those tables and process that information. And it'll basically shut your network down. You can lose your communications. So these are the types of things we're trying to protect against. Some other things are what are considered man-in-the-middle attacks, such as DHCP spoofing. There's also ARP spoofing. There are replay or playback attacks as well. Some other things that can happen, of course, when you focus on using the MAC ID, for example, as a security measure, you can have devices that can spoof a MAC ID, and it can pretend, if you will, that it is that particular device on the network with that specific MAC ID address. Of course, you have passive wiretapping and snooping of information, where they can get unauthorized access to the network, and then they're just collecting data. They're just looking for information. They're not really trying to shut the network down, but they're just collecting data. Then there's VLAN hopping attacks, spanning tree protocol attacks, and multicast brute force attacks. So all of these things, and actually much more, of course, are all the things that we have to consider when we're connecting our devices to the outside world. And that's why the security is a big part of the network connections, not just a reliability within house. We want to make sure it's secured when we connect to the outside world. So how does MAC security work? Again, this is encryption-based communications between two ports, for example, on the switches. This is, again, based on the IEEE. This is the 802.1AE. And all we're doing basically is we're encrypting information between the frames between the two ports, and just saying, okay, this data is going to come across. It's encrypted from this port to the another port, so port 7 to 8, for example, on another device. And then the other device can decrypt that information, use it, and then share the data with multiple devices. So between these two, for example, the data would be encrypted. And so what that does is, if someone for some reason was able to get past whatever security measures we had in place and was able to access this connection point because the data is encrypted, well, they can't do anything with the information. So it gives us another layer of protection. And unfortunately, a lot of times this is the place that is overlooked. So that's why we tend to focus on this a little bit, especially within our switches, because at that layer 2 protocol level, it's kind of one of those, it's kind of an afterthought for a lot of people. So the MACsec or MAC security switches offer an open standard. This is nothing that's proprietary for any user or anything like that. It's an open standard that can be used across platforms, again, encrypting that data. The secure channel in the MACsec is unidirectional and used for transmitting data or receiving information. The connectivity is a association between the MACsec is enabled, consists of basically the 2 secure channels that I mentioned. The one is the outbound and inbound. We use 16-digit hexadecimal numbers for SCI or secure channel identifiers. Also, there's a 32-digit hexadecimal number for secure association keys as well. So again, this is an open standard. It's not unique to any manufacturer or proprietary in any way in that sense. So earlier I talked about the authentication, and then of course the data integrity is what we just talked about. So a lot of times those 2 components, if you will, are considered part of that MAC security or the MACsec security that's offered. So as I mentioned, the 8021AE is the encryption, and then the 8021X is all about authenticating the devices and ensuring that they are supposed to be connected or authorized to transmit data between devices on our network. So the authentication part of that, of course, is with the Radius server. And we always talk about the AAA, authentication, authorization, and accounting. And that's what the Radius authentication server does for us. And using the, authentication server, the authenticator, and then of course the field device, the PLC, in there as well. MACsec uses integrity check value safeguards against data tampering, again, encrypting that information from between the 2 devices. So here's a really good application example. You can see we have our SCADA system, could be going to a cloud. We could be using MQTT, for example, as our communication to the cloud or SCADA system, or OPC UA. And then we have our control side down here with various systems we're trying to control. It could be lighting, could be temperature control, PID loops, things of that nature, flow control, all of that. But we place these MAC security devices on our network. We encrypt the data from point to point here, and then we don't have to worry about when we send this data out to the outside world that someone has potentially access to this information inside the facility or within the application. The nice thing about these types of security measures is all Ethernet protocols can be encrypted using this method. And it supports industrial protocols like Ethernet IP, Modbus TCP, Profinet, and so forth. Also, as I mentioned, you can do this with MQTT, Sparkplug, OPC UA. All this can be handled with regards to this data encryption. So there's no lag or loss of information or potential interface issues. Another part of security, of course, is firewalls. So we want to set up firewall protection between the outside world and our devices. So depending upon what ports we're using, we can set up filtering data packet systems for like source MAC or source IP address based on that, I should say. Are we going to, how are we going to communicate to this PLC, for example? So here, for example, we're using port 443 to communicate with this, and only that port. So we can limit which ports this device can utilize to communicate with the PLC. Same thing with a third-party device or some other system that's on the control level. We want to limit, okay, only this device can use this port to communicate here. So we're using the firewall to set that up, okay? and even on the maintenance and service PC. So again, that's another thing that we can set up to ensure that only certain devices can communicate and gain access to our systems. We can also do port security based on MAC-based firewalls. So this is where it can dynamically learn the MAC address for each port, right? Creating that like CAM table, as I mentioned earlier. It's going to limit which MAC address can use which port. And we can create these white lists and black lists for each port, you know, who has authorization, who doesn't, to go through this port to send data or request information or just have access to the device in general. We also can set up another level of not just security, but also data transmission control, which is important on networks, has a lot to do with reliability and security, is having these VLANs set up, okay? So it allows us to segment our groups into logical virtual networks. So we can do different things like broadcast limitation, security improvement, because we're separating these network segments from one another. Could be we have a group that's just for controls and a group that's just going to our platforms that are putting data out there for the production control manager. We can set up data flow prioritization on here. So again, controlling the information that goes from device to device. And it allows us to subdivide our machines and office networks from one another, isolate them, if you will, to a certain degree. Even though we want to send data across those networks, we want to separate or segment those groups. There's a couple of ways we can set this up. One is IP-based VLAN. So basically, we're routing the data packets between the VLANs based on the IP address of the device that we set up, of course. It can be from one participant in 2 or more VLANs across the networks that or the VLAN connections we've set up. It's pretty easy to set up. And again, it allows you to prioritize the data packets based on the IP address on the device. So that would be something, either you could use DHCP to automatically set those up, or you could use it, you can set up the IP addresses manually, but then you can set up your VLANs and the connections between those. We can also do this based on MAC ID. So of course the MAC ID is something we don't change. It's fixed on the device. It comes from the Mac manufacturer, excuse me. And it allows us to use that unique or specific MAC ID to set up these VLANs. Again, doing the same thing we were doing in the previous slide, we're just using a different way to establish the connection between the devices and allowing that authorized transmission of data and communications. Another thing we have to be concerned about, of course, is performance. So we have a lot of things that we're trying to do as far as controlling, if you will, the information that's going across our network. And so we have different ways we can do that. Here we have the link aggregation system, where it allows us to merge multiple data connections into a single logical link or point, if you will. So it allows us to increase our transmission rate because we're focusing as far as the communication, who's doing what and how it's being handled. It gives us our ability to use that link redundancy. So again, if one connection fails, we don't have a single point of failure. And anytime we use this link aggregation, our goal is for 2 things: to increase our bandwidth and our network resiliency, excuse me, with regards to the devices and how they're sending data back and forth. So again, it's not just reliability, redundancy, and security measures, but it's also performance, as I mentioned earlier. Another thing that we can do to increase our performance on a network is have this traffic prioritization and control bandwidth. So we can set priorities on here of the data packets per the IEEE 802.1Q. And what it allows us to do is limit the bandwidth or number of packets per unit of time per port. Okay, so you can see we can set priority levels for different ports, for the devices that are connected to these ports. And as far as when that data needs, which one has the highest priority, a normal priority or low priority. So if we're just transmitting a low priority message, of course, a high priority comes in, it takes precedent, if you will, over the low priority information. And of course, this can increase our data transmission quality. And again, ensure those high priority packets of information get to their destination faster in a more timely manner. Another thing that you have to be concerned with is these broadcast storms. I kind of alluded to this earlier when I was talking about that multicast brute force attack, for example, or the denial of service where they're flooding the network with information. So the switches can allow us to set up the device to protect us against these broadcast storms. If you get a broadcast, somebody maliciously sends one of these into your network, of course, you can shut it down. You can't transmit information, you know, loss of information, loss of control of the system. So again, it's all about network availability and limiting the broadcast and multicast data flows between the systems, the components in the system. So just to kind of wrap this up a little bit with regards to the information and the things that you have to consider on an industrial control network, and again, sharing this information, transmitting this data out across the network. I want to talk about security a little bit and some best practices, because this is one of those things where, you know, people think, well, all I need to do is X, and there's a lot more to it. There's a lot more layers to this. Obviously, the stuff I mentioned previously with regards to the switches, with reliability, the network security, firewall options, and all that. But there's also things that we can do within our system itself. So some of the best practices that we need to consider, some of the things that we need to look at or really be as part of our plan of attack when we're connecting our systems to the, especially to the outside world, are first, of course, passwords and logins. So when someone wants to access our network, we want to make sure that they're logging in with the appropriate credentials. I mentioned segmenting the networks, you know, separating your office LAN from your industrial control side. And of course, even when you're transmitting data out into the cloud, and how we want to handle that data, how do we want to segment the devices from one another so that we ensure that secure connection to the devices and secure our data as well. Of course, encrypted connections, we want to use things like VPNs so that we can make a secure connection from end to end. The use of firewalls and filters. We talked about that briefly about the firewall side, but even the filters, you know, creating these white lists and black lists of devices, for example, that are allowed to communicate on our network. You know, you control your service entrances. When do you want to use certain ports over Ethernet? And if they're unused ports, what do we do about that? And then another thing we'll talk about is demilitarized zones. So we're going to hit each one of these just for a few minutes and talk about their importance. So first of all, passwords, logs, and logins, right? We all have different passwords to log into different things within our company, within our emails, private, you know, professional, whatever the case may be. Obviously, anytime you have a device that has a standard password that's documented for everyone to see, you want to change that. One should be one of the first things you do. Okay, so make sure your passwords are unique and documented internally within the organization, and use different passwords for different applications, different ports, or whatever the connections could be. So you can see, for example, we have a web interface that may be used on a PLC. And to access this web interface or web-based management tool, we need a username and password. So we want to make sure we set that up. Again, changing the default password that came from the manufacturer to something unique within our organization. Some of these PLCs and systems today have these consoles where you can log in without a web interface or without the programming software. And immediately when you go into something like that, especially when you look at like Linux-based systems, you want to log into that console and immediately change the default password. And even within the programming tools, right? So each system, you know, your PLCs, they have a programming tool designed for that device. You want to set up a password for that. Hopefully your control system, the manufacturer has set up a means for you to password protect logging into the device with the programming tool. And so you want to make sure you utilize that option. You know, it's one of those things that people can enable or disable. Unfortunately, a lot of times they just say, well, I don't need port authentication. We'll just have anybody log in. Well, you're opening yourself up for potential problems, obviously, with that. As I mentioned before, your segmented data networks, we talked about doing this with a switch, but just in general discussions here, we should be looking at how we segment our data networks outside of even the conversation of using the managed switches. How do we separate these groups from one another? How do we want to set this up efficiently, right? You know, you don't want your office LAN connected directly to your industrial control system. And now you're trying to run a process on the control side, and some guy in your company is trying to download, you know, a 4 gig video file that he saw on YouTube or something. So, you know, it's one of those things where you want to definitely make sure you separate these groups from one another. And a lot of control systems today, whether it's within the managed switches or even within the PLCs, allow us to set up these 2 ports on here to isolate, separate, or segment our network. The other thing, of course, is firewalls and filters, as I mentioned earlier, not only in the managed switches, but even within our devices, okay? So we want to make sure that we set up these layers of protection using multiple ways of doing that, right? Whether it's passwords, firewalls, filters, you know, whatever the case may be. So first of all, you can see where we can set up like MAC address filters. So we say, hey, only certain devices with a specific MAC address group or specific MAC address to a component device are allowed to send data to our PLC. All the rest is garbage. We don't care. We're going to throw it away. We can also set up packet filters where we say, all right, only information coming across a certain port, okay, is allowed to come to this device. So not just the MAC address filters, but packet filters based on the Ethernet ports we're using for our system. Encrypted VPNs and remote access, you know, this is a big thing for a lot of people where they want to be able to log into their device, maybe remotely test the system, check out the system health, maybe run some updates remotely, things of that nature. Well, in order for them to have that connection remotely, they have to have it secured from end to end. And the best way to do that is utilizing a VPN. You know, several manufacturers offer different solutions. For example, IP security is basically just a suite of protocols that were developed for ensuring that integrity and confidentiality of the data communications and using that authentication between the 2 devices to ensure that it's authorized, that person or device is authorized to access our network. OpenVPN is another one of those. It's another open source connection protocol, allowing you to set that secure connection, that virtual private network, or that tunnel between 2 points in a network, between 2 devices across networks. And you set up this authentication with certificates. You would create your certificate here, for example, and then send it over to the device. And then later down the road, you can have that secure connection between the 2 devices and not having that unauthorized access while you're making that connection. Another thing is to control your service entrances and remote access. I just talked about using a VPN, but also those ports that are there are available on the PLC. It could be a programming port. It could be a port for telnet, file transfer protocols, HTTP, HTTPS, some of the other services, secure shell connections, the web visualizations on a device. So if it has the ability to create its own, or you can create your own web pages on the device, all of these different things. So when we look at the various service ports that are on these devices, it's a simple rule. If it's unused, disable it. Right? Don't leave a port open if you're not going to be using it or utilizing it within your system. You leave that port open, you leave the door open for someone to potentially use that to access your information or shut down your network or whatever malicious act they want to perform. So you have to be mindful of that as well. So again, if it's not used, turn it off. Again, here's just showing you a different way to look at that and with the different various protocols. So we have these control devices sending information out to the cloud. we can take a 2-port device and have those. We can do a combination here where we have our network segmented. So this port maybe is going to the cloud. This port down here is going to our control system. We have firewalls set up between the devices. It could be within devices or routers and switches in between. And then, for example, on this X1 port, we'll call this guy up here X1, we're only sending data via HTTPS, where our X2 port is going down to our control system here. And you can see we have all these service ports enabled. Now, typically we wouldn't do that. We wouldn't have them all enabled, but just to give you an idea, so we can separate the network segments, and then each port can be configured to enable or disable certain Ethernet ports specific to what we're going to use as far as the different services. A demilitarized zone. So set this up so that you can push that data between systems or out to the cloud, which are isolating maybe the control side. So here you can see we have our internet connection could be to a cloud-based system like AWS. And then we have our first firewall and router where we're controlling, in this case with the red line, a lot of data is flowing back and forth. We're kind of open this up to allow things to go out in and out of this point here, okay? So easy flow of data. But we have another router and firewall set up here for our internal network to protect these devices. So we can easily transmit the information to here, and maybe he relays that information onto the cloud system, okay? But this connection to the outside world potentially isn't direct from here. So we have this demilitarized zone where this middle device here collects the information, sends it out to the cloud, but we isolated the control side completely from that, okay? Now, final tip here, if you will, on the security side, there's a lot of things that you need to look at as far as the different things that you want to implement within your system, as far as security, reliability, redundancy, and everything. What you have to figure out is what your system can tolerate, right? How much can we put into our system security-wise without there being any issues or problems? And use that defense in depth concept, layer things up. Have multiple solutions for your network security, whether it's VPNs, firewalls, passwords, encryption, whatever. People will often say, Mark, well, what's the silver bullet? What's the one thing you would do for network security? And I always tell them there isn't one thing. Okay. Just like you see here in this illustration, you have a single piece of paper, easily ripped, easily bypassed, if you will, from a security standpoint. So not just firewalls. I'm going to layer it up like you can see with this phone book here. You can't rip the phone book as easily. You can't get through it. So I'm going to have firewalls, VPNs, encrypted communications, set up some VLANs, make sure I have my own authentication, whether that's with passwords and logins, users, or authentication, as I mentioned, with Mac security. So it's all about layering those things up to give you that reliability and that security within your system. So that concludes my presentation with regards to network reliability and security. Hope you found this information informative and useful. Again, keeping in mind all the things that we have to consider across the board when we look at applications like this, and all the things that we can do potentially from our network connection into the system and firewalls all the way down to the switches and the devices themselves, and setting up, as I mentioned, VPNs, VLANs, passwords, encryption, and so forth. So thank you very much for attending.
Thanks, Mark, for such a comprehensive introduction to this technology. For our viewers, we look forward to seeing you in the live Q&A session immediately following. Be sure and have your questions ready. Thanks for joining us, and we hope the information provided will suit your purposes.